Alright, so this is a discussion about the chapter 7.1 to 7.4 test. I just want to go through these problems with you because I'm not going to be able to share your individual tests with you. So the first problem here is finding the degree, leading coefficient, and then classifying the polynomial. Remember, the degree of a polynomial is the highest degree of its terms. So here we have a degree 4. This term has a degree 4. And then this term over here has a degree 3. And remember, to find the degree, it's the sum of the exponents of the variables. So here we've got a 2 and the invisible 1. 2 plus 1 is 3, degree 3. Here we just have the 4 on the x as its exponent, so the degree of the term is 4. So the degree of the polynomial, again, is the highest degree of its terms. So this has a degree 4, so the degree of the polynomial is 4. All right, the leading coefficient is the first coefficient when the polynomial is written in standard form. So if I were to put this in a standard form, well, look at this. We have degree 4, degree 3. The degree is decreasing left to right, so therefore it's already in standard form. So the leading coefficient is just the first coefficient, or the first number before the variable, which is 8. The answer there is 8. The next one says classify the polynomial. Well, remember, terms are separated by addition or subtraction. We have an addition sign here, so we have 2 terms, which means that this polynomial is a binomial. All right, moving on to the second one. Essentially the same process here, except this one is not in standard form already because we have degree 2 plus 3 is 5. This term has degree 5. The term to its left has degree 2 because of the y squared. And then the first term here, a constant. Remember, you could always write a variable to the 0 exponent next to that constant because x to the 0 would just equal 1. So the degree of this constant term is 0. So to put this in a standard form, the highest degree must go first. So 5x squared y cubed plus 4y squared, the next highest degree, plus the constant at the end, 7. All right, now that it's in standard form, it's easy to pick out that leading coefficient, the first coefficient of 5. The degree, again, is the highest degree of the terms. In this case, is 5. And then the type of polynomial, classify the polynomial. So one last time, terms are separated by addition or subtraction. We have 2 addition signs in this one, which means we have 3 different terms. So there are 3 terms, which makes us a trinomial. All right, so that is the first problem on that test. Moving on to the second question here, it says find the sum or difference of the polynomials. So here we are combining like terms. Because this is addition, these parentheses are not going to change the result of the problem. So I'm just going to rewrite the initial problem here without the parentheses. So essentially you're distributing a positive 1 here, which is not going to change the value of any of these terms. So drop out the parentheses, combine like terms. We have 2x to the 5th plus 2x to the 5th, so I have 4x to the 5th. We have a 3x to the 4th here, and then minus 3x to the 4th there. Those 2 terms are going to cancel each other out. It will equal 0. Here we have a minus 2x, a negative 2x. And here we've got a positive 5 plus 5. So that is the answer to number 2, part A. Moving on to part B. On this one, it's a little bit different. We've got a negative out in front of this trinomial, so we have to distribute this negative 1 onto all 3 terms before we're able to get rid of those parentheses. So that negative changes the sign of all 3 of these terms. So we have from the original polynomial, or the first polynomial here, 7m squared plus 2m minus 5. And now negative 1 times 7m squared is a negative 7m squared. Negative 1 times positive 2m is a negative 2m. And a negative times a negative here gives me a positive, so that's a positive 4 plus 4. At this step now, we don't have parentheses, so combine like terms. 7m squared minus 7m squared, those 2 terms are going to equal 0, cancel each other out. Positive 2m and a negative 2m are going to cancel out, equals 0. And the negative 5 plus 4 is a negative 1, and that is the answer to part B. All right, number 3, it says find the product of the given polynomials. Now we are multiplying two binomials. Remember, you have that acronym FOIL, F-O-I-L, first, outside, inside, last. But on this one, we have that pattern that we can apply. These are both subtraction, and each of these quantities are the same, and each of these quantities are the same. So remember, in class, we said this is the same thing as A minus B times A minus B, or A minus B quantity squared. And that is going to give us, we've already FOILed this pattern out in class, that gives us A squared minus 2AB plus B squared. And we're able to apply that pattern on this one. So we can call X A and 4 B, and then just plug X in here for A and 4 in here for B. So we end up with X squared minus 2 times X times 4 plus 4 squared, which ultimately is going to give you the answer of X squared minus 8X plus 16. And as I said, on this test, this first test of this chapter, you are able to, if you did not remember that pattern, you could do as I just did and actually write it down and FOIL this out, or you could FOIL the two binomials together, and on this test that would be acceptable. But again, on the next test, you will have to know how to start here and go backwards, and it's much, much easier if you have this pattern, as well as when we do something called completing the square, you're going to need to know this pattern. So yeah, you could have FOILed this one out, but I highly recommend you learn these patterns, because if you didn't already, you will have to know them shortly. All right, on the next one, this is a subtraction, this is addition. We have the sum and difference pattern here. So we have the same value in each of these spots and the same value in each of these spots. This is the same as A minus B times the quantity A plus B. And again, we FOILed that out in class. We saw that when we FOILed this out, the two middle terms cancel out. When we FOILed this one out on part A, the two middle terms add together to give you this middle term. They don't cancel out. So there's the difference between these two examples. So in part B, when you FOIL this out, you get A squared, you would get plus AB minus AB. Those are going to cancel. And then negative B times B is negative B squared.
Associates, please head down to the middle.
Okay, so here we've got A squared minus B squared. So A is X, B is 7. So that's going to turn into X squared minus 7 squared, or X squared minus 49. And that is the answer to part B. All right, going on to the next one. On this one, it says find the products. Well, here we do not have A minus B and A plus B. These quantities are different, and these quantities are different. So some of you tried to apply one of those patterns on this question, and that does not work. You would have to have the same quantity in each of these two spots and in each of these two spots. So here, when it says find the product, all you can do is FOIL this. So again, FOIL first. The first two in each binomial get multiplied together.
This excuse the interruption.
We multiply the outside two together, so x times 3x. Then the inside two, negative 1 times x squared, and the last two, negative 1 times 3x. So what that turns into, x times x squared is x cubed. The outside two getting multiplied together gives us a 3x squared, positive 3x squared. The inside two multiplied together gives me a negative x squared. And the last two, a negative 1 times 3x is a negative 3x. So in this one, we do have some like terms. The middle two terms combine. 3x squared minus 1x squared is going to be 2x squared. So the answer to this one, x cubed plus 2x squared minus 3x. All right, going on to number 4, part A. It says solve for the given variable. Well, remember when we're solving these equations, I'm going to use part B as a reference. On part B, we would have to take out the greatest common factor first, and then it's going to look like part A. So part A is already essentially halfway done for you. This is already what's called factored form on the left-hand side. We have two factors getting multiplied together, and their product is 0. Remember the zero product property. So the zero product property tells us if two quantities are being multiplied together and we get out a 0, one of the two must equal 0. One must equal 0. That is the only way you're going to have a product come out to be a 0. So we apply the zero product property. We say x plus 4 must equal 0. That's one possible case to turn this expression into a 0, or x minus 1 could equal 0. If either one of the two terms equals 0, the product will be 0. So subtract off 4 from both sides, we get x equals negative 4. Add 1 to both sides, we get x equals 1. So x equals negative 4 or x equals 1 are my two solutions, and I show that by putting them in a set in numerical order. So negative 4 and 1 are the two possible values of x that would turn this into a 0 and make that statement true. All right, part B here, as I said earlier, you have to start by taking out the greatest common factor, or the GCF. So the greatest common factor between 6n and negative 12n squared, while both 12 and 6 are divisible by 6, a couple of you on your test, you tried to take out, what was it? It wasn't a 6. I think you took out a 3. That's not the greatest common factor. So you always want to look for the greatest common factor. It will make solving a little bit easier down the road. And also when we go to factor, you have to always take out the greatest common factor. And that'll be coming up later on in this chapter. So taking out 6, that's the largest number that 6 and negative 12 are divisible by. And then we have an n and an n squared. Both of those are divisible by n. So 6n is the greatest common factor. And now, what would remain when you factor out 6n? Remember, that is the opposite of distributing in. So if I were to distribute in 6n, I better get a 6n. So 6n times what gives me a 6n? Well, 6n times 1. And then 6n times what would give me a negative 12n squared, and that is a negative 2n. So when you factor out a 6n, essentially you're just dividing each one of these terms by 6n. You could always double check yourself. You could distribute or multiply back in the 6n into the parentheses. 6n times 1 is 6n. 6n times negative 2n is negative 12n squared. So the expression looks different on the left-hand side here, but it still is the same value. All right, so at this point, now we've made it look like part A. We have two factors getting multiplied together, and their product is 0. So again, use that 0 product property. If you're multiplying two factors together and getting out a 0, one of the factors must equal 0. So either, in this one, case number 1, 6n is 0, or 1 minus 2n is 0. So setting each of these equal to 0 and solving them will get you your two answers that would turn this into 0, or make that equation true. All right, so divide both sides by 6, we get n equals 0. Or, on this one, subtract 1 from both sides, we get negative 2n equals negative 1. Divide both sides by negative 2, and we get n equals positive 1/2. So there are your two solutions. We show that in a set in numerical order, 0, 1/2. All right, going on
Pardon the interruption.
All right, going on to part C. So on your test, some of you tried to factor out a 4 on this one, and this is actually incorrect. If you factor out a 4x, what you'd end up with is an x minus 22 divided by 4. Now, is 22 divided by 4 an integer, a whole number? And the answer to that is no. So that is not, 22 is not divisible by 4. So you cannot factor out 4x like some of you tried to do on your test. We're always looking for integers when we take out the greatest common factor, when we divide out the greatest common factor from each of the terms. So here, the largest number that both 4 and 22 are divisible by is a 2, and then x squared and x are both divisible by x, so 2x is the greatest common factor. So now what remains when you factor out... I keep getting interrupted by announcements at our school, so let me try to keep going. Where was I? So I factored out a 2x. Again, 4 and 22 are both divisible by 2. 22 is not divisible by 4 because 22 divided by 4 does not give you an integer. So if I factor out 2x, again, just think about what would you have to multiply 2x by if you were to redistribute it to get a 4x squared? And the answer to that is 2x. Another way to think of that is 4x squared divided by 2x is 2x. All right, so I've got a negative 22x dividing out a 2x, I get negative 11. And it still equals 0, so I still need to put equals 0 here. All right, so now I'm going to apply the 0 product property. I've got two factors multiplied together, and the product is 0. So one of the two factors must equal 0. Either 2x equals 0 or 2x minus 11 equals 0. Divide both sides by 2 on this equation, and you get x equals 0. On this one, add 11 to both sides, so 2x equals 11. And then divide both sides by 2, you get x equals 11 halves, or 5 and 1/2. So in numerical order, my answers are 0 or 5 and 1/2.